going to be covering today is some of the development considerations on the client and server side, some of the tools that we provide, especially some of the new ones with respect to page speed compilation and the Diagnostics Module, which can help us to identify some of the things that are going to hurt your performance when you're doing custom development, things like N+1 problems and long-running queries on the database. Most of the performance issues that we see do have to do with grabbing too much data from the database or asking the database for data too frequently. So it's that connection that is really going to be a large limiting factor there, especially with the fact that you can do the pre-compilation of the pages, which is one thing that does take a little bit of time with ASP.NET, but with them pre-compiled when you deploy to production, it really is going to be from then on just about that database connection largely. We're also going to be talking about useful customizations and practices. So I'm going to be showing you some code that we have in order to do custom trace listeners, in order to log any errors that you're getting on your Sitefinity sites into an external error logging service. In this case, I'm going to be using rategun.io, which really does help in terms of keeping track of everything that's happening, any errors that we're getting, and making sure that we address them in a timely fashion and knowing what exactly happened. The other thing is the web test runner, which is something that we've created so that you can write integration tests, which are something that if you really want to be checking out how things work within Sitefinity, if you're developing very custom modules and you need to be testing them within Sitefinity, how they integrate there, as opposed to just unit tests where you are mocking stuff up, you can do that with our integration test runner. And that actually has both a GUI client and you can run them via the command line. The other things we're going to be talking about are a little bit about deployment architecture. Things like system requirements, common setup scenarios, and deployment. So for people who don't have a lot of experience deploying Sitefinity, just sort of the basic setup, sorts of things that we see people doing a lot with respect to how code flows around, how content flows around, how our load balancing works in various systems, and things that you may want to be considering when you are doing deployment. So a couple of things that we're going to be talking about from the development side. These are things that we find that people forget to do the most often and do cause the most problems. On the client side, it usually results from people using jQuery and using their jQuery selectors, but not doing things with caching their jQuery selectors. Every time you call a jQuery selector, it traverses the entire DOM in order to find it. So if you aren't caching them, every time we make that call, we have to do that again, and that gets very expensive very quickly. So if you know that it's going to be called more than once, you really should be caching it. Other things, on the server side, use paging and filtering, and do that during your calls out to get data. Make sure that you're only grabbing data as you need it, so that you aren't necessarily grabbing all the news articles at once and then filtering them down to only the ones that you want to be displaying. This can be a big thing with junior developers and people who aren't as familiar with the way in which you grab data. The other thing is that we want to be using link deferred execution. One of the reasons that we built our API and our data model the way we did, in the fact that it returns iQueryables, is the fact that we want you to be able to use link deferred execution, so that you are only making those calls when and if you need that data. That being said, I say most of the time because there are some issues that you will run into occasionally because we are using an ORM. ORMs are great. They're great for accessing data, but they're not perfect. They tend to have issues with respect to N+1 problems. And for that reason, you need to understand when you are grabbing data from the system. You need to know at what points you're going to want to actually make those calls if you are having performance issues. And we do have some tools that can help you to identify N+1 queries in order that you can actually run the first query, get your data, and then use it to manipulate your second query so you aren't running hundreds of queries because of the N+1. So the first thing, jQuery selectors. So as I mentioned, when we select an element with jQuery, it traverses the entire DOM tree. DOM traversal is expensive. If we use a selector more than once, it should be cached. The way in which we do that is making sure that we do things like setting it to a variable. So if instead of using this highlighted items.click, if we just use this actual selector there, the query would not be cached. It wouldn't be something that, so anytime that click action happened, we would be traversing the DOM tree again. So in cases where we do know this is something API supports it, and it's especially easy to do if you're using the Fluent API. Just being able to say app, work with, news items, get, and then skip and take in order to do things like paging, so that we're only actually grabbing those 20 items when we need those 20 items, as opposed to getting everything and then filtering it down. It's one of those things that can be very sneaky, especially when you're just starting out. When you don't have a lot of content, you won't see performance issues. But as the system gets used more and more, they'll start to build up more and more, and you'll start to see problems. Last thing, like deferred execution. So it's the reason we return iQueryables as opposed to lists. A lot of it, ASP.NET developers, we were used to using lists because they're easy to manipulate. We can get items in and out of them very quickly. They match up with sort of the data structures that we learned when we were learning programming. It's very easy to understand how things get in and out of there. The problem is when we call to list, it forces the query to execute, and it forces us to put all that information into memory. This can become very expensive very quickly. So you want to be doing all of your manipulation that you can on that iQueryable, and if possible, just binding the iQueryable directly to the data structure that we're trying to populate with data. As I mentioned before, the caveat here is sometimes we need to force a query right now in order to save an n+1 later. And that's something that's more, you'll find when you're doing performance tuning, as opposed to something that you're going to know right away when you're writing the code. At least at first, when you're just starting out. Sometimes you'll be able to find those types of queries that are probably going to be problematic earlier and be able to go after that before it even becomes a problem. But talking about tools, PHP compilation was added very recently to Sitefinity. We have a tool, it's in our documentation. If you search our documentation for PHP compilation, there's a command line utility that allows us to point at a site, pre-compile the pages, so that when we do something like deployment to production, we don't have to have that warm-up time while all the pages are being compiled. We don't have that CPU load, which can be a big thing during deployment, or if we're recycling our web app. There's also the Diagnostics Model. This is a new thing that we've added that not a lot of people, I think, know about or have turned on, but we're able to actually use SQL Server profiling along with some other things that we built on top of it in order to understand the types of requests we are making of our database in terms of operation runtimes, in terms of n+1 query problems. We have some custom reports so that we can, there's a lot of data that gets generated by these reports, and being able to single out exactly what those long running queries are and those things and filtering it down quickly is stuff that those custom reports can do. And you can actually add to those. And in our documentation, we tell you exactly how you can add a custom report if you find there's a certain performance problem that you identify that we're not filtering for you. So I'm actually going to, at this point, jump out of the presentation for a moment and show you the Diagnostics Module. So inside of our dashboard, same quantum dashboard we've been working with all day. In our administration section, we have our diagnostics area. Now, this is on, and you will need to configure a separate database connection in order to have this work. And we tell you how to do that in our documentation. So under our diagnostics module, when we turn it on, it starts database profiling. We have over here our operations and our n+1 query problems. These operations, we put them into categories like HTTP requests, how many of them are happening, the status they're returning, when they're starting and ending, and their duration. And we can filter by all of these categories so we can quickly isolate what's taking a long time, what isn't, where that URL actually is. And if we show more or click into one of these, instead of just showing the HTTP request that was happening in terms of requesting the page, we're able to actually see all of the database calls that go along with this. So being able to see exactly what was called, number of statements that we're working with, affected records, the duration of these queries that we're running whenever we're browsing around our pages, and the provider name. This can be useful if we're trying to figure out which content type was it that we were trying to call that is causing this issue, so it can narrow down very quickly which widget is causing the issue. And of course, this is all within our RAD grid or our Kendo grid, so we can do all the filtering that we need to do in order to very quickly hone in on one of these queries that's causing the problem. back to the report, checking out our N+1 query problems, we actually do have a few of these in here. And the thing is about these is that we built it in such a way that these are not necessarily for sure N+1 query problems. These are just potential N+1 query problems. And we can dig into them and we can see exactly what the database call is, and we can identify for ourselves if this is a problem that we can alleviate either by tweaking the way in which we're loading data and accessing data through the API. So there's that, and there's also some things that we can do in terms of thresholds, and this is actually a very low threshold that I've set so that we can actually have some query problems show up. The custom reports area is really just using the information that we're gathering within this Diagnostics Module to run these analyses. So there's the big result set, so when we're actually loading in a lot of data, when is that happening? And then the long-running query analysis. So things that are probably going to kill us in memory and things that are just taking a long time. And of course, we have the from and to date, so since I've only had this running right now, change my alert threshold to maybe 4 and run my report. Nothing is actually in here. Let's get this down, see if we can actually get something to show up. But you'll definitely get a feel for 12 a.m. to 12 a.m. and that is not going to work. 12 a.m. to 11 p.m. So we can see these queries that are coming in, and it's the affected records that we're pulling in, which is what we're pulling in for the big result set analysis. For the long-running query, it's the duration in milliseconds. So to run one of those real quick, let's say it's more than 3 milliseconds, it's going to be too long for us. We can see all of our long duration calls. So quickly filtering in to see what's happening with the database, and then turning it into stuff that we can act upon. So just clearing that out, and we'll jump back to the presentation. Again, just an overview of the things we talked about with the Diagnostics Module, operation runtimes, how long is stuff taking, N+1, tool to highlight those N+1 query problems. Lazy loading is great, but sometimes you run into trouble if it causes one of those, and you need to be aware when you need to force prefetching. One of the things that you can do in order to force prefetching without having it affect things too much in terms of the way you code is to denormalize things by projecting your data into new objects, and when you do that projection, you're actually going to force an execution, denormalize things, and hopefully avoid hitting that N+1. And if you actually, if you haven't done this before, you just do a quick Google on projection and N+1, you'll find some strategies on how to do that. It's fairly common, and something that people run into with Link a fair amount. So a couple of useful customizations that we include with the SDK that you can install. Custom trace listeners that we'll look at in just a little bit, log errors to external systems like Ray.io, keep track of all the errors that are happening anytime, even if we're suppressing them for user interface purposes. One of the things that we do with our widgets sometimes is we suppress that big error so that we don't break the user interface and confuse users in the UI. You still do probably need that stack trace, and you want to store it in a system that's going to allow you to manage it and address that bug in a meaningful way. So we built out things that do things like log2Ray.io and the web test runner to run those integration tests that we build out when we're building out large customizations that involve custom modules that may be built out entirely in code, as opposed to with our custom module builder, or if you're building out things that really do rely heavily on the internals of Sitefinity in terms of the data model. Just to show you those two things actually implemented, switch out again, and this time I'll show you it as opposed to showing the blank screen. All right, so if we look within Visual Studio, we have a couple of external projects within the Sitefinity web app. The first one is our external logging. On our documentation, we actually have a walkthrough of how to implement this exactly in terms of bringing this into your project and using it directly to use Ray.io. And And there are a few different things within here that I don't really have time to walk through all the way. But let it suffice to say that basically we're just using web services to push information out into Raygun.io using their API. All you have to do is put in your API key pretty much that they give you when you sign up and are creating a new project, and use the module that we provide for you on GitHub. So if we get into Sitefinity again, and we go to our pages section, and in this case, let's go to our home page and we'll trigger an error. So let's say on our list down here, we're going to edit, and we're going to, let's say, under our settings, edit our selected template, and we're going to add, in this SF data field, it says content. We're going to say contents, which is not actually a data field that we have for our lists. Save our changes. We now have a template which is making a call to data that isn't there, and it's going to, this kills the list. So when we try to do things like preview, hopefully I will get my error, but I don't. I thought this worked, but maybe we'll get it. Or maybe I didn't save it. As is the case with all systems, when you don't want them to break, they will, and if you do, they won't. So in that case, let's actually just look at some of the things that I've had logged as I was doing preparation for Chicago. So for example, sometimes when we're trying to access applications that we don't have running, or we have a server error on, we're getting our 500 errors. Ultimately, we can see the machine that this is coming in from, what happened. So in this case, I was trying to access our online shop page, so we know that our error is on there. The request timed out, and we get an HTTP exception. Those are not terribly interesting because they don't have full stack traces, but if we did want to look at a full stack trace within Raygun, there are some more interesting ones like our null references exception, which I ran into when I did this before, in terms of looking for an object instance that is not there when I was trying to visit the site view. And what's cool about Raygun is that we're able to deal with these in our dashboard view, have them as active error reports, and then we're actually able to move them through a system in terms of resolving them, trying to reproduce them, those sorts of things, ignoring them if we think it was just a one-off kind of thing, and making sure that we're logging all of the errors that our customers are running into when they're using our systems. So. All right, the other thing I wanted to show you was our web test runner. So in our integration tests, we have, there are a few things that I've loaded into our Sitefinity web app in terms of references, in terms of loading our integration test into here, along with a few things that are actually running our integration tests, like Galileo. And when we actually look at the tests that have been built out, we have some very simple ones where I just want to show that things are working, where we have a passing test where we have an expected value of 2, actual value 1 plus 1. We're asserting that these things are equal. Of course, that's going to pass. We have ones that are going to fail where we're asserting that things aren't equal, where they aren't what we expect them to be. Those things are, of course, going to fail. But these are just very simple things that are full tests. One of the nice things about the framework that's included here is we also can run setup and teardown. So if we need to do things before we run tests in terms of creating objects within the system, but after our tests are over, tear them down, we can do that as well. And if we look at some of the more advanced tests that we've built out here, we can see a little bit of that. So in this case, we're testing some of our document libraries. We're testing, adding new documents to our document libraries to make sure that that's working, making sure that things are or are not equal in our tests so that we understand exactly, are things as expected? Are things changing? Things like associated with that site. We can run any of these tests individually, or we can run them all at once. And we're able to see very easily the results of all of these tests, whether they failed or passed. And this is just the GUI that we have for it. We're also able to export these results into Excel. The other portion of this that we include within the SDK is there's that client that we were just looking at, but we also have the command line, and there are instructions on GitHub on how to use that command line, so we can call it by like a PowerShell every time we do a build. At this point, I wanted to start talking a little bit about architecture. Some of the stuff is going to be, of course, very simple for anyone who's used Sitefinity before. Of course, I have to start off with the most basic things so I can sort of outline, just what is in the system. Ultimately, Sitefinity in its most basic form is just that production server running IIS, and then our production database. We have our incoming requests, we serve them, we use the database to store and build out content. Very simple. That being said, we support a number of scenarios in order to support more advanced network architectures, things that deal with multiple different stages within our content, within our development, how code and content flow through these. And this is actually an example of one of the most common infrastructures that we see people using. Because we don't charge for pre-production domains, people feel very confident building out this staging and development infrastructure because it doesn't really cost them anything, and it really is good practice. So what we end up doing is we'll generally see our developers, they'll have a local instance of Sitefinity running, something where they can actually build stuff out, do their widgets, do their basic testing to make sure that they're confident that this is good code. They'll check it into an automated deployment infrastructure. Usually that's something like Git or TFS, as source control, and then the deployment infrastructure will be something like Visual Studio Online or TeamCity or Octopus Deploy, where we can have many different build configurations in order to build the project, run tests, and deploy it to whichever server that we need it to be deployed to. Generally, the code, of course, goes out to development first, which we have as really just a development area. It may have a database that mirrors our staging or production environment, just in terms of having content within the database that we can test against to make sure that our code is really working. Our staging environment really is a place where we often see people having our content authors log in and create content on a non-production area that can be then synced up to production when it's ready, when it's gone through its workflows. It's also where we're going to be sort of user acceptance testing any new code that we're writing once we've gotten past development and we're really feeling like that code is going to be ready for production soon. At this point, when we're moving from staging to production, again, automated deployment infrastructure is really going to handle that code deploy, but we are going to generally see people relying on SiteSync in order to push content from staging into production. SiteSync can be triggered via the API, thus can be triggered by an automated build process. You can build out web services to trigger SiteSync. So this can be a nice way to package code together along with the content that it supports and push it all into production in one go when you are building out these infrastructures. Just to show you the sort of content flow, ultimately, just because some people, it can be a little bit confusing as to how SiteSync works. Ultimately, what we see happening is when you're a content creator, you're coming into our staging server over port 80, over HTTP or HTTPS. You're creating your content. That content gets stored in our staging database. At a given time when we do decide to SiteSync, we're basically sending out a request where we're saying, over port 80, we want, first of all, our staging server to retrieve the content that we need to sync, and then push it over either port 80 or port 443 for security reasons into production. And the way it pushes it into production is as a user, we're pushing it in much the same way that anyone was. There's no actual connection between these databases. And for this reason, we're doing things like our staging and synchronization synchronization stuff, avoids things like GUID collisions, and issues in actually migrating the whole database from here. And we're only really pushing the changes over in a way which also mimics the way in which users create content. And then actually our content ends up in our production database. Just sort of standard code flow deployment strategy. You're going to need to be testing on every level. You're going to want to be checking in and promoting from each of your different environments, just so that you are testing both whenever you're checking the source control, when you're pushing to dev, staging, production, and making sure that whenever tests don't pass, you go back to the beginning and figure out why, and then move it through that deployment strategy to make sure that only good code does get deployed. As I mentioned earlier, a lot of the things that we see people using for source control are Git and TFS. Both are supported by Visual Studio. Both are supported by Visual Studio Online. And Visual Studio Online has added recently a number of automated deployment tools that can make it very easy to set up these deployment strategies, have them run, and have them run differently for different servers, and then actually drop the files we need onto the servers once builds are complete. What we were seeing a lot of earlier tended to work with KingCity and Octopus Deploy, which are both great tools, both more focused around that automated deployment, but ultimately the fact that Visual Studio Online is a Microsoft tool and it is the way they are moving with TFS, I think that in the future we're going to see a lot more of it. So just talking about the site synchronization API, ultimately this is all up in our documentation. All you're needing to do within the things that you're writing that are going to use the site sync API, have your using statement, grabbing the facade, using the Fluent interface to do this. We can use select target, so we select our target server by its URL. That's going to be the base server that may be serving up many things within a multi-site instance. And that's why, even though we're selecting via the URL, we can set our site, so we can select which sites we want to sync our content to. We can select the types of content that we want to be syncing. In this case, this statement is actually syncing out probably all of the news items. We can sync out things for a specific language. If we wanted to say this particular news item and only for this current culture, or only for a specific language like English, Spanish, whatever it is that we need to be syncing for. We can schedule the sync for later. And this is something that we're actually building out more of with our 8.1 release as well, in terms of being able to schedule these synchronizations and have them deploy when we want them to deploy. And it just uses a cron format so that we can schedule our sync of specific content at a specific date and time. So talking a little bit more about Sitefinity and load balancing. So we of course support load balancing. We support it on a hardware, software, and in Azure scenarios. The first one is with one of our simple load balancing scenarios where we have our two servers, and we have our load balancing add-on, which handles our cache invalidation as we change content on these servers, letting each server know when its cache is invalid and what parts of that cache are invalid. This load balancing add-on is communicating over port 8 and calling web services on each server. It's not going to have to do much setup with the load balancer, but they are also going to be sharing that one database on the back end, be it a clustered database or a single server. We of course also support the software load balancing. We see this used probably the most often on on-premise solutions where we have network load balancing between these two web servers. We still have the load balancing add-on dealing with our cache invalidation, single database on the back end. The last scenario, and the one we're starting to see more and more of as people are more interested in moving deployments into the cloud, is Azure. And the reason we see a lot of Azure is because we've made special integrations with Azure in order to handle some of the things that you might have to set up otherwise within Sitefinity. So we see our web servers running in with Azure Cloud Services, which is not a full VM, it's just the cloud services, and we can run full Sitefinity on there. We integrate with Azure load balancing so it can handle things like the cache invalidation for us, so we don't have to set that up. And these are easier to spin up because there's not as much configuration we have to do as we need to scale up. This can be a great option if we have the sorts of sites where we don't know how much traffic we're going to have on them on a day-to-day basis, so we can sort of expand and contract as need be and really only use the resources we need to. Another thing I would like to point out is that we do support SQL Azure. SQL Azure is a great database for a lot of reasons, and geo-restore is a really great feature of this so that you don't have to set it up yourself. Even if it isn't quite a hot VR, it'll help you get back up and on your feet very quickly if you do have a disaster. So, as I was just talking about, database and web servers in SQL Azure, load balancing, we support both, and that load balancing add-on is necessary for cache and validations. A couple of just deployment suggestions. If you're using a hosting service for your production environment, use that same environment for your UAT and staging. I've had a lot of people ask me, can we have our UAT and staging inside the firewall? Can we have those on-prem and have our deployment be out in the cloud? And the answer is yes, ultimately, but really the whole point of a UAT or staging environment is that it's going to try to mirror production as much as possible. So we do want to have that set up be as clear as possible so when we do move content, when we do move code into production, we don't run into anything that's going to surprise us. For cost reasons, we commonly see people use staging in development. They share a database server just because the load on them is so low. Different databases, of course, so we're separating out the actual content, but just so we aren't wasting any of that database capacity. Also, we see dev is really just for code testing. Content is mostly being added on staging. Any dev code that gets pushed up is more in the user acceptance testing phase. When we occasionally see 4-tier deployments, but not as much. This tends to be for organizations that are very, very concerned about what gets into production and want to make sure absolutely 100% that there's a level where they are really only doing testing and there's no content creation. The last thing I wanted to talk to you about is some of our professional services, and this was something that we mentioned a little bit earlier. So when we talk about writing code, when we talk about deployment, when we talk about all these projects that you may be doing as partners of ours, we do want to support you in that, and we do offer our professional services for that. It's a very small team. It's made up of some of our most accomplished developers and former sales engineers like myself that have been doing basically a lot of custom work and working with some of our very large customers and partners in order to tackle very advanced projects, bring stuff in where you may not be able to tackle it on your own if you're having trouble finding a problem with one of your deployments. These people are sort of there to help you in order to get to that very quickly, in order to mentor your teams, in order to train your teams. And I have a huge amount of respect for them, just because I know all of them personally, and they're all some of the best coders I know.
Christopher, if I can speak to that for just a minute, because you're spot on with that, and I wanted to tell everyone here that there's never any shame in reaching out to professional services to be a part of your team.